So today what we're going to be doing is we're going to be looking at how to write equations from either a graph after we transform that graph or from an equation after we transform that equation. Okay. All right, so we've spent the last week and a half looking at how to either write an equation from the description or write an equation from a graph or graph it from an equation. But today we're going to kind of do a combination of everything. So look at example 1 under section 1 here. It says new equations from a transformed graph. Write the new equation for the given graph after the transformations are performed. All right, so what our goal is right here is to be able to take this, transform that graph, and then write that new equation after the transformation. So let's focus on this one right here. It says, given the graph, write the new equation of the graph after it's transformed 1 unit to the left. All right, so everyone put your point right there on the original vertex. Okay, always start by focusing on either the vertex, the point of inflection, or the initial point. Okay, so let's move it 1 unit to the left and then 5 units up. So 1, 2, 3, 4, 5. That is the new vertex. So again, we took our original vertex, we moved it to the left 1, and then up 5. All right, so what is that new vertex? -1 and 5. That is our H and our K. All right, so now we want to write the equation. And so I'm asking you to do two things here. I want the equation of the original equation, the original graph, and then I want the equation of the new graph. So let's do the original graph equation first. That vertex is 0, 0. Now I notice it's opening down, so I know it's been reflected. And I see that if I go down 1 over 1, I'm not back on the graph. So where is the graph on the corner of the grid? Right here. So let's find that rise and run. What is your rise? 3. And your run?
1.
So your A value is 3 over 1 or just 3. So that original equation would be y equals -3 times the absolute value of x. Because your h and k are 0, so you don't need to put the x minus 0 plus 0. But for the new equation, we do have an h and a k. All right, so is that going to be a x minus 1, or is it going to be an x plus 1? Plus. Because what we actually do here is we say x minus your h value, and your h value here is a -1, so the negative of a negative gives us that positive. Okay, our k value is a +5. Did it say that we shrunk or stretched any more than we already had? No, so the 3 is still there. But what's happened now, it said it reflected over the x-axis. So if it was originally opening down, when you reflect it, it's now going to do what? Open up. So do I need to put that negative right there, or does it stay positive? It stays positive. Okay, so that's all we're doing. Notice I didn't try to regraph the whole thing. I just focused on that important point, either the vertex, the initial point, or the point of inflection. All right, and number 2, we have a square root function. All right, so let's go ahead and pick out that initial point. What is our original initial point? 3, -1. Okay, so we could go ahead and write this equation. So we got y equals the square root of x minus 3, and our k value is a -1. But I noticed instead of opening up, this one's actually opening down, so we have a negative in front.
Is that the original equation?
Yeah, that's the original equation. So this is, when it says original, they're talking about the one they give you. Oh, I see what you're talking about. Just kidding. This actually goes right here. Thank y'all for pointing that out. Alright, so now what we're going to do, we're going to move it. Alright, so it tells us we're going to go 4 units to the left. So take your initial point and move it 4 units to the left. 1, 2, 3, 4. 3 units down. So 1, 2, 3. So that's where the new initial point is. Alright, so that new IP, we got -1 and -4. Alright, so it's going to give us y equals, alright, it didn't say anything about being reflected, so we're going to keep that negative, so negative square root of x plus 1, our new h value, and our k value is -4. Alright. And then the last thing it tells us that we have a vertical stretch of 2. Well, that's the easy part, because all you're going to do is put a 2 in front of everything. So put a 2 right there. So again, take notice that I'm not trying to move everything, am I? I'm only moving that one point, because what really is happening is you are moving everything, but if we just need to focus on that one point, we can write our equation. We just need the h and k. All right, with that in mind, let's let number 3 be a U try. So take about a minute and a half and try number 3. Bless you. right, ready? All right, so our original vertex is at -2, -1. Okay, so our original equation would be y equals, it's opening up, so I know it's positive. Okay, if I went up 1/1, I saw that there was no shrinking or stretching going on, so we're going to have x plus 2 squared minus 1. All right, it's asking us to transform the unit 4 units to the right. So let's see, 1, 2, 3, 4. 3 units up, 1, 2, 3. There's my new vertex. And that is 2, 2. And then it's going to have a vertical shrink of a 1/2. So when I go to write my new equation, I've got y equals 1/2. That's just simply your a value. Then we'll have x minus 2 squared plus 2. Questions? You writing this down? All right, finally for number 4. Now number 4 is probably the most difficult one. It's a cubic function, and the fact that it's cubic is not the difficult part. The difficult part is that we have a scale factor there. We've got to be able to figure out that scale factor. Okay, so let's just start with our original point of inflection. All right, that original point of inflection is 3, 0. All right, so with my parent function, if I go from the point of inflection, if I go up 1/1, I'm seeing that I'm back on the corner of the grid. But right here, if I go up 1/1, am I back on the corner of the grid? Yes or no? No. So that means it has a scale factor. So we need to determine that scale factor. Okay. So we're going to try to find where is that point where it's on the corner of the grid. Now, this is not exactly perfect, but we're going to just say it is. We're going to say it's right here. Okay. All right. That regular point is 5, 3. That is your x and y. And remember, this is your h and k. So we're going to have to actually find the scale factor before we do anything else to it. Do you remember how to find the scale factor from yesterday? Somebody be brave and say, substitute everything into the equation. There we go. All right, so let's come right here. Let's write our equation out. We got y equals a times x minus h cubed plus k. All right, so what we're looking for is our scale factor. We're going to substitute in for our x and y and for our h and k. And once we do that, that's going to leave us with just a. I think you dropped your phone. All right, what is our y value for just the regular ordered pair? Not h and k, but just the regular y. 3. So I'm going to replace that y with a 3. We don't know what a is, but I do know what x is. What is the x value for just that regular point? 5. All right, what is my h? 3. And what is my k? All right, so that's the hardest part right there, is to remember to substitute in for x and y and h and k. Now we only have one unknown, so we can solve this by just doing order of operations. What's 5 minus 3? 2. So now we got 2 cubed. So what's 2 times 2? And times 2 again? So what we have is 3 times a, how about 8 times a, plus 0. Do I need to put the plus 0? No. So what's the opposite of multiplying by 8? So here my a value is 3 over 8. So the original equation right here would be y equals, all right, my a value is 3/8. I see it's rising to the right, so I know it's positive, times x minus 3 cubed. I don't have to put this k value of 0. Now that we've figured out the original function, we're going to take that point of inflection and we're going to transform it. 2 units to the right, so 1, 2, 7 units down, 1, 2, 3, 4, 5, 6, 7. That new point of inflection is going to be 5, negative 7. Okay, so that's going to give me y equals 3/8 times x minus 5 cubed minus 7. I just substituted in for my h and my k. And then, so I got this part out of the way, I got that part out of the way. Now reflect over the x-axis. So what do I put in front of the 3/8? A negative. So that is the hardest one, where you have to find the scale factor first. All right, so that's from graphs. Now from the equations are a little bit easier. Okay, because with the equations, you already have the equations, so it makes it pretty easy. Everybody got this copied? All right. All right, so writing equations from transform equations. Okay, so here we're given y equals the square root of x minus 7 plus 4, and they want us to dependently write this down. Okay. All right, so I actually want to go down to part B first. I meant to flip-flop these, but I didn't. It was kind of late last night when I was typing this up. So I want to come down here and do B first, independently. Independently simply means that you're going to go back to the actually let's do the correction right here. Change this right here to independently, and change this right here to dependently. So when you're doing it independently, you can go back to the original equation each time. Square root of x minus 7 plus 4. All right, so what we're going to do here is we're going to write our equation. We've got the square root of x minus 7 plus 4. And we want to be able to figure out how to work this algebraically. So they want us to move this simply to the left 3. So we're going to take this and move it to the left 3. 1, 2, 3. What is our new h value? 4. So we got the square root of x minus 4 plus 7. No, not plus 7, plus 4. So nothing changed other than we just shifted it over to the left. Now, you think shifting over to the left we should subtract 3, but we actually ended up doing what with the 3 algebraically from what it looks like? We went from an x minus 7 to an x minus 4. How do you go from a negative 7 to a negative 4? Add 3. You're going to find that anything you do with the x, you always do the opposite. So all we did here is simply add 3 to the x, and we got the square root of x minus 4 plus 4. All right, for part B, independently again, means you go back to the original problem. So we're going to go back to the square root of x minus 7 plus 4. Down 6. If you're moving vertically, is that impacting your h or is that impacting your k? Your k. So we know with the k we keep. So down 6 means we're going to subtract 6. 4 minus 6 is negative 2. All right, for part C, write 2. So we've got the square root of x minus 7 plus 4. All right, write 2. Is that impacting h or is it impacting k? H. So write 2, we think we're supposed to add 2, but we're actually going to subtract 2. So this is going to be the square root of x minus 9 plus 4. And is there a way that you can verify this? Yes. You can put the original equation in, and like right here, I would go to line 2, put x minus 9 plus 4. Did it move from to the right 2? Well, here's my original, 1, 2. So yes, it did move to the right 2. All right. Try D. Let D be a U try real quick. All right, about 30 more seconds. All right, write 5. Should I subtract 5 or should I add 5? I should subtract 5. Up 4, should I add 4 or subtract 4? Add 4. So here we're going to end up with square root. Negative 7 minus 5 is going to be negative 12. And 4 plus 4 is 8. So these aren't too bad at all. These are easier to me than the graphs, because the graphs you have to go in there and figure out the original and then everything else. All right, x minus 7 plus 4. We want to move it to the left 2, so we're going to add 2. Up 4. I got fixated on up 4, didn't I?
Yeah.
So we're going to add 4. We end up with the square root of x minus 5 plus 8.
reflective. It's reflective.
Oh, thank you for the reflection. Yes, thank you, ladies. All right, and then for the reflection part, we're just going to throw that negative in front. All right, and our last one. Okay, right 4, we're going to go and subtract 4. Down 3, we're going to subtract 3. So it's square root of x minus 11 plus 1. Then we got a vertical stretch of 2, and then a reflection. All right, so just to write ourselves a little hint, if it says left, we're going to add. If it says right, we're going to subtract. If it says up, we're going to add. And if it says down, we're going to subtract. All right. Dependently means you go to the previous answer to get to the next answer. So you use the previous answer and work that previous answer to get your new answer. So once you write down that original equation one time, you're done. You keep using the new answer. So with that being said, let's write down our original equation. So we got y equals x minus 7 plus 4. All right, in part A, it says left 3. So if it says left 3, we know we're going to add 3. So that's going to give us the square root of x minus 4 plus 4. This is your answer for A. Now, here's the new part. We're not going to go back to the original equation. We're going to use this answer right here to do the next piece. All right, part B says go down 6. So if you're going down 6, you're going to subtract 6 from your your k value. So that's going to give us the square root of x minus 4. And then 4 minus 6 is negative 2. So this is your answer for B. See how I'm using the previous answer to get to the next answer. That's what it means by dependent. Like you are your parents' dependents. You depend on them for a lot of your things at the moment. All right, for part C, it says right 2. Okay, so right 2 we think we're supposed to add 2, but we're actually going to subtract. So that gives us x minus 6 minus 2. So here's our answer for C. All right. For D, it says right 5. So we know we're going to subtract 5. Up 4, we're going to add 4. X minus 6 minus 5, so negative 6 minus 5 gives us 11. And negative 2 plus 4 gives us 2. Now I'm going to rewrite that right here so I have room. All right, for E, it says left 2, so we know we're going to add 2. Up 4, so we're going to add 4. Negative 11 plus 2 is going to give us negative 9. And 2 plus 4 is 6. And then I got to go in there and add that reflected part. So I'm going to put my little negative right there. And then finally for F. F says write 4. So we're going to subtract 4. Down 3. So we're going to subtract 3. Negative 9 minus 4 is negative 13. 6 minus 3 is 3. But now it says reflected. Well, if this was already negative, when you reflect it, it becomes a positive. And then we've got a stretch of 2, so we put that 2 in front. And this is our final answer.